Hello, I'm Chuck Dewey, an R&D engineer here at Keysight Technologies. Today I will be talking about the X8712A solution with wireless connectivity in this case. Sometimes you're not always have a shield box or a wired connection to your device under test, and sometimes you will need to use an external antenna to pick up the DUT. You can do this, and you can actually get effective power measurements of the DUT with an external antenna. However, you might run into some issues with setting the RF levels of the solution. So here what I have is I have my external antenna. And one very important thing to keep in mind whenever you're using a single port on the solution, you will want to have a dummy load. This gives you accurate and consistent measurements of the RF power. So I have my DUT connected to the power and the RF detector connected in. We'll go over to the computer and do some initial acquires of this DUT. So what we'll want to do is do an initial acquire of the RF signal so we can get an idea of the levels that we are receiving from this external antenna. So what we have is we have it set in a single mode, so it will trigger right away. We'll do an acquisition, and we will look at the levels we're getting from this external antenna. Now, I have the data series tooltip turned on so I can read the levels off the screen here. You can see I have a fairly high background noise of -18 dBm coming into this external antenna, and as I scroll across, I can see that it's going up to approximately -10 dBm on the signal from the DUT itself. So what we'll want to do is we'll want to change over into triggered mode and set the trigger above -18 but below -10. I also have a couple little spikes here coming in. They're about -15. So just to be sure, I will set my trigger level at approximately -14 dBm. So if I go down here into trigger, I will change it into triggered mode, channel 2, which is the RF detector, and I will set my trigger level to -14 dBm, and I will reacquire. And we'll see now we have nice spikes showing the matching of the current and the RF signal. You can see here my RF signal is -10 dBm and my current is actually 7 milliamps. So that shows the DUT is actually transmitting. Now if I look down here on the analyze, it looks like I'm using 100% always in transmit. Well, that's because you need to change the levels for analyze to match your environment where you have a high background. So I have something at -18 dBm, so I will want to set my lower threshold somewhere significantly above that, -15 dBm. And hit the analyze once again. Now you can see that in this case the occupied time is 0.85%, so only 0.85% of the time is this DUT in this state, but it's using 31% of the power, so you can see the transmission is actually using most of the power. In this case, with a 240 milliamp hour button cell battery, I get a total life of 1.37 kilohours, or 1,370 hours of life with a button cell battery. Thank you. This has been Chuck Dewey with the X8712A solution with wireless connectivity.